So welcome back one and all. Last time we dealt with singleton design pattern, which allowed only one instance of our entity manager, as well as indices, which allow us to get or set specific characters. As you can see, Mario's that are moving differently there. So that's all cool. But today we are going to deal with another little more interesting, not so much, class, and that's going to be our character class. Character entity. Excuse me for a sec. Sorry. Sorry about that. So we have a character class. It is going to be in entities dot characters. It's going to be the namespace, and it is going to be public. Now we have game entity, but we don't want ever to actually have an instance of game entity, so we're going to make it abstract. So now we will never have an instance of game entity. So let's save that. And character is going to extend from game entity. Cool, eh? Also, I'm going to want to import all of our X and A. So now we have our character class, character entity, which extends from game entity. Now there's a few things in game entity. We have a few methods that I want to override, sorry. But unfortunately I can't because I'm missing a keyword. Before we had the keyword abstract, which didn't declare a body, but we already have a body. So what if I want to override load content? Well, I have to use the keyword virtual. Virtual. And this will allow me to override load content or anything. It's the same as abstract, except it's allowed to have a body. It also means I don't have to necessarily override this, and I'm not going to, because you know what? The load content for my game entity would be the exact same for my character entity. It's not going to change. So why change it? I don't want to override this. But I will make it virtual because maybe in the future I will override it. And the same for the draw. The draw is not going to be overridden because it's going to be the exact same thing. Virtual. But I'll make it virtual in case in the future, which in the future we will override it slightly. But I'll make it virtual. So now abstract basically means there's no body and you are required to override it at some point. If your class is abstract, you don't necessarily have to override the abstract method. However, any class that's not abstract, you do have to override it. So what I'm saying is character entity, remember we have draw as a method in iDraw, which is an interface. I can delete all this, and since my class is abstract, I can put just the keyword abstract and I don't have to actually implement a draw function. But I'm going to, because most of the stuff that's going to inherit from game entity is going to use the same draw. So I'm going to leave it as virtual, so now I can. It's already overridden, meaning my future classes don't have to override it. So I don't have to override draw or load content, but I do want to override update because I don't want all this crap in there. Virtual. And what I'm going to do is I'm going to remove all this crud. If I can get it to cooperate. I'm going to remove all this crud. Remove this. I'm not going to really have much. I'm going to leave my update just like that for now. I'm going to put a to-do. Add functionality. There's going to be a little functionality in there a little later. But I will want to override update. So let's override update. It's simple, public, override. and I'm going to want to override update. Notice update calls base. It's basically just going to go the base one. This is what you would do if you want to override, draw, and load content. You'd pretty much just call the base dot draw base dot load content. So this is why I'm taking it out, because we can access it directly. Because this function, since it inherits, this class inherits from here, it still has access to these methods. Alright, so we have all that, but our load here is going to be slightly different. And well, we have this. Take these fields, take this out, and we'll delete that. So that's pretty much our character entity class is complete for the most part right now. And I'm going to add in the field rotation. Boom. So now we have the update that's different from our base class, but our draw and load are going to be the same, and we're going to have to create a constructor. Let's do the public and create a constructor called character entity, and this one's not going to take in any values, and it's just going to call the base default constructor for now. And then we're going to have one character entity that takes in the string name. Generally, the good idea is to create a constructor that matches anything you inherit from. So create a constructor that adds, because if we go back to base, remember game entity actually has a constructor right here that takes in a name. So we're going to not override, but we're going to create a constructor in our character class that also has a name that passes name in. So that's all good for now. So now that we have that, let's run it. See how well it works. Oh, we get an error though. Cannot create an instance of abstract. Oh, okay. That's because we're trying to create a game entity which is now abstract. We can't do that. So first, let us import or get a using statement for our character. And we're going to change game entity to character. So there we go. Now that should run it. Oh, runs perfectly. Whoa, 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 wait. Wait a minute. All I did was change this, but Mario's still a character entity. Well, that's the idea of polymorphism, is the fact that since character entity derives from the base class game entity, that means character entity. So when we create this new instance, character entity, it is a character entity, but it is also a game entity as well. And since game entity inherits from base game entity, it is also a base game entity. So you see how it works? Mario Hero, which is a game entity, character entity is a game entity, character entity, game entity, and base game entity. So yes, Mario is, this character instance right here being created is a game entity as well. Now, if it does not work the other way around. If this was a character entity, you can't create a new game entity if it wasn't abstract. So you can downcast, you can't upcast. That doesn't really make much sense right now. But yeah, since character entity is indeed derived at some point from game entity, it allows us to do that. So I don't have to change anything other than that one line of code. The program still works. Everyone's still flying. Everybody's having fun up there. Is that not cool or what? So as you notice, I'm changing less and less and less in my program as we move along. So what's our character gonna gonna hold? Well, our character entity represents anything that can take damage, pretty much. It represents our player, enemies, bosses, yeah, basically anything. So Mario, Goombas, and King Koopa is basically what all these character entities are going to represent. And what do all those characters have? Well, they have health, right? So we're going to have private, uint, health. We're going to have a second field, max health. Because we need to know what's the maximum amount of health a character can have. Because Mario only has, depending on which game, but in the first game, I believe, he only has 2 hit points. Basically, when he gets hit once, he goes back to Little Mario, and then when he gets hit again, he's dead. So those are our 2. So let's set them up in our constructor. So max health, we'll say, equals 100 for 100%. And our health, we're going to want our character to start out at max. So we'll say max health. Just like that. And we're going to want to do the same thing in this one as well. We're going to want to have a max health. So that's all the same there. I will create the properties for this later in a minute, but I'm just going to keep it like this for now. So there we have the max health and all that. Wait a minute. I'm having to repeat this. What happens if I want to change my max health to something else? I would have to change both these values. What if I forget? That causes problems. So let's create ourselves what's known as this constant. It's going to be public, static, or no, sorry, public, static, const, uint. This be default, health, and we're going to say it's equals to 100. I can't remember if this actually works. No, I caused an error somewhere. So I can't mark this as static, unfortunately, which is fine. So we'll delete the static. There we go. Yeah, and we'll set it to here. We'll copy this. So anytime I want to change the default health, I'm not going to have to worry about these. They'll change automatically to become 100 later. So that's good, but what happens if I want to set the health to be something specific without having to go in and change the properties? There we go. So we'll do a character entity. So string name. And now I want to set the max health. Right? So max health. So now I can actually change the max health so it's not 100. Max health equals max health. Now normally if this was an integer I would have to actually change it to check to see that it's not under 0 because we don't want to have a negative health value, right? But since it's a uint, it's going to reverse. If somebody puts in a negative, it's going to wrap around to be positive. And then we're going to set health equal this dot max health. So that's good. So that means our character is going to start out with max health, whatever the max health. So if you put it as 50, our health is going to be at 50. But what happens if we want, say, like a shooter where our character starts out at their max health is 200%, but you want to start them out at 100? Well, we'll have to create another constructor. Notice the constructors are getting bigger and bigger as we go up the hierarchy because we're now at like level 3. We have character entity, game entity, and then base game entity. Name uint max health and uint health. This dot max health equals max health, and this dot health equals health. So now we have a character that pretty much has, you can set their health, and that's all good and dandy. Our update here all works as normal. So what else would we want to do? Let's see. Well, we want our character to attack, right? Want him to cause damage. So we'll have a public virtual, because later we might want to override how it acts. So we'll have a calculate damage, which basically takes in a uint damage, and for now it's just basically going to take the health and subtract equals damage. Oh, I didn't have a modifier. Or sorry, return type. Void. A lot of voids. So basically, yeah, what's going to happen is when something gets damaged, it's going to come in here and it's going to cause damage to the health. So that's pretty cool and all. We might also want a character to attack, so public virtual, because public virtual void attack, and it's not going to actually be a void, it's actually going to be a uint. Actually no, it's going to be an int. And no, I'm not sure. I'll leave it as uint. And basically we're just going to return, say, 50 for now. Now this is going to become later, because I don't want to actually do anything with it. Later this is going to become abstract. So I'm going to, because I don't want to actually do any damage calculations in the character entities. I want to force people who inherit from this class to do their own attack calculations. I'm just going to put a to do, make abstract later, so it reminds myself. This one's going to be virtual because they can keep the basic one where damage just decreases the health by whatever you pass damage into. But yeah, that's about all that's going to happen there. So if they choose to override it to maybe do different damage calculations, like add defense to the character or something, that's their choice. So let's make some of the properties. So public uint max health get return max health set max health equals value. There we go. Public uint health get return the current health. No. Oop. Health. And set is going to obviously set the health to equal the value. So there we go. So now we can set our health and get our max health. Actually, I don't want to set the max health because I don't want to actually change max health. But you know what? Somebody later might want to change that. So I'm going to make this virtual. And I'm going to make this one virtual as well, because maybe they might want to change what happens here. Sorry. Now I'll put in a set, but it's going to be a dummy set. So in case somebody wants to set their max health later, they can do so. If I did not put that set in there, they wouldn't be allowed to override the set, I believe. So I'll leave that as a dummy set, and I'll set this one because we're going to want to set the health up and down depending on what happens. But there's another method or another property we're going to want to do. How do we know when our character's dead? Well, that's easy. We want this to return a Boolean because we want to check if they're dead. We're going to call it is dead because it makes sense, right? Is they dead? True. Is they not dead? True. Or is they dead? False. So we're just going to have one that's a get. And it's going to return true or false depending on what their current health is. So what do we say? You can put an if statement, but I'm going to show you the little nifty little question mark operation. So we do our condition first, which is health. Is health less than or equal to 0? And remember, it's a question, right? Is health less than or equal to 0? It is. If it's less than or equal to 0, return true. Else, with the colon, return false. But we have to return. So we put that there, and I forgot the semicolon. So there we go. That's basically all our character really needs. It's not really anything fancy or visual that we can represent at this time. But that's about what we're going to need for the most part. Like I said, chances are stuff like this will come out later, because later we're going to want to make character entity abstract. We don't want character entity to ever be created. You're going to keep wanting this stuff to become abstract and abstract until you get to such a fine point where you're actually defining the player and the enemies. But there we go. Like I said, later this will become abstract to force people to write their own attack function, and this one's virtual in case they want to override it later to do different calculations for when they attack and such. And there's all our constructors. So yeah, the constructors are getting more and more complicated, but the code is getting to be easier and easier, one-liners and stuff like that. So there we go. That's not really anything fascinating, but that will be it for today. So folks, thank you for watching, and Mario's going to fly backwards. Let me know. Give me any comments or questions just to let me know. Also send in any sprites or anything you want me to add. I'm getting tired of using Mario. So yeah, thank you for watching, and have a good day. Bye now.